Hello again, Helier College math students. In this video I'm going to be talking about scale ratio, and you can see here I've got a photo showing a scale model of a city. So this looks like a scale model of Chicago, which is a city of course in America. So scale ratio is really useful for creating something like this where people can walk around and look at different aspects of the city and do it just in a room and see the whole city scaled down to this size. Of course, extremely useful for maps. Increasingly these days maps are going digital, so people are using satellite navigation in their cars or on their phones to get to where they need to go, but those are still scaled down versions of the places where people are travelling. So we still need to use scale even in digital maps rather than paper map. We still need that, and of course extremely useful for helping us navigate places and not get lost. So scale ratio has been a critical aspect of exploration, particularly early exploration. Now, we don't just scale things down and shrink things that are really big to small size. We also want to scale things up sometimes. So, for instance, bacteria, things that are really small insects or just microscopic organisms like this, we might want to blow them up, as we say. Not blow them up like a bomb, but make them bigger and larger so we can actually see them with our own eyes rather than having to use a microscope. So scale ratio can go both ways. It can involve scaling things down, so making big things small and making models of those things, but it can also involve scaling things up, so things that we normally couldn't see with the naked eye, we can look at models of those. So this would be particularly, for scaling things up like bacteria, particularly important in the world of medicine, for instance, and finding cures for different bacterial infections. Okay, so let's look at the types of questions that we'll be confronted with in our course. And here we have the scale ratio, and this is so that people get an idea of how, well, for instance, if we're looking at something that's been scaled down, like on a plan or a map, how big is the thing in real life? You might be looking at a map and it's only a few centimetres to get from one place to another, but you'd want to know what scale has been used on this map so that you could have a rough idea of how far it is to get from one place to the other. You might need to know how much petrol would be required if you were driving a car, or how long it would take if you were walking. So you need to know the scale so that you get an idea of the distances, the real life distances that are involved. So here we have a scale with 1 to 200. So what this is saying is that the first number is the size on the map, and that could be, say, just 1 centimetre across the page on the map. And in real life, that's equivalent to 200 centimetres. So 1 centimetre on the page is 2 metres in real life. Everything in the map, for instance in this situation, is 200 times the size of what is on the map. Here we've got example 2.1. Let's have a look at this. Now we've got a house, a battleship and a space shuttle, and of course these things are all much larger in real life than the representation we see in front of us here. Now with these types of questions, what you're asked to do is measure the size of this object on the page and then use the scale that's given to determine the real life size of the object. So I've done some measuring here. You might want to pause the video and take some measurements. I've done mine in millimetres, so you guys could do that too. Centimetres are okay, but the answers I'm going to give use millimetres. But of course we're asked to express our answers in metres. So if you want to pause the video and measure the length of these arrow lines, and it's from the very, I'm going from tip to tip, okay? So from the very tip of this arrow to the other end, the entire length. Okay, so I'm going to put my measurements down, and if you disagree with me slightly, that's okay. In a test situation with these, if you were like a millimetre different to me, I'm not going to worry about that. It's just whether you use the numbers correctly afterwards, which is what we're concerned with. But I think this is 26 millimetres long. Very important you put the units down. I think this arrow here is 53 millimetres, and the one for the space shuttle I measured as 38 millimetres. Now, if your numbers are slightly different, don't feel that you have to change them, but you would proceed with the same mathematics as me from here on. Now, how do we use this scale to blow this up into to find the real life measurement for the height of this house? Now, I'm going to do something here that might seem a little strange at first, but there's a good reason for this, just trust me. We're going to take the number, the real life, and divide it by, so real life, oh, forgot an L there, real life divided by, I'll just rewrite that, the, I suppose the measurement on the map. So let's try that again, real life divided by map. So what I mean for this one, it would be the real life is 250 divided by the map 1. Now, of course, for all of these, we're dividing by 1, so we just get that same number. But sometimes this might be a number other than 1. The scale might be 2 to 250 or something like that, and then you'd get a different number there. So that, when you come across those examples, try the same method as I've used here. That'll help with those sorts of ones. Okay, so when we're going from the plan to real life, we multiply by that number, so times, yeah? So here we've got 26 millimetres by 250. And that gives us 6,500. And it's because we've used millimetres here, we're going to use them again here, same unit. Now we've been asked to do this in metres, so you might want to pause the video here and do that conversion to metres. And perhaps you'd leave the video paused and try these ones using the same method as I've used here. So I'll let you try that. Okay, I'm going to do it now. So let's see. This first one, 6,500, we want to go convert that to metres, so we'll divide by 1,000, which gives us 6.5 metres. Does that seem realistic for a house? Yeah, what is it, about 2.5 metres per storey. So a 2-storey house would be something like 6.5 metres. Some are a little taller, some are a little shorter, but that seems reasonable. If we got an answer like, 1.5 metres, well, that wouldn't be a very big house. So just think to yourself when you do these, does that seem feasible? Does that seem about right? Okay, so 2,000 over 1 times 53. So this one is 106,000 millimetres. When we divide by 1,000 to get that into metres, 106 metres. That seems pretty reasonable for a battleship. They're big. Okay, and 1,500 over 1 multiplied by 38 gives 57,000 millimetres. When we convert that to metres, we get 57 metres, which I think is reasonable for a space shuttle. They're big too. Okay, now the next set of examples doesn't have pictures. Here they are. I'm going to have a go at this one and change colour here and that one. All right, and then show you those two, and then you can pause the video and I'll put the answers down, straight down for the others, and see if you get the right answer. Okay, so for this one, let's see, we're going, for the ones I mark, the blue ones, which is these first three are, we're going from plan to real life. So just like on the previous example, we're going to multiply. Now these last two are going opposite. They're going from the real life to the plan. So in that case, we're going to divide. So these two little statements here are something that you might want to put on your cheat sheet for this, for measurement. So you remember which way around is the multiplier and which one we need to divide for. Alrighto, so let's give this one a go. Same as before, 100 over 1 multiplied by 5.2 centimetres, okay, which is 520 centimetres. Or in metres, divide that by 100, 5.2 metres. So in this plan, 1 to 100 scale, 5.2 centimetres on the plan is 5.2 metres in real life. So it's interesting that with the 1 to 100 scale, however many centimetres you have, that's what the real life measurement is in metres. So that works nicely, a 1 to 100 scale. Pretty easy to do. Okay, this one here, the red one, I'm going to do this here. Okay, so we're talking 1,000 over 1, which gives us 1,000. Now we need to divide the number, the measurement, so it's 120 over 1,000. And that gives us 0.12 metres, which, if we're not told to do this, but if we converted that to centimetres, would be 12 centimetres. So you might want to pause the video now and go ahead and try the others, and then I'll put the answers down for those. Okay, so I'm going to have a go at those now. I'm going to switch back to blue. So plan to real life. Here, this one was 200 over 1 times 36 millimetres, which gives 7,200 millimetres, or 7.2 metres. 1 to 50. Okay, so we're still going from the plan to the real life. So 50 over 1 times 15 gives 750 centimetres, or 7.5 metres. Okay, last one down here. 50 over 1 is 50. And then we have our 3.5 metres divided by, because we're going from real life to the plan, so we use divide. And that gives us 0.07 metres, because this was in metres here, which is 7 centimetres. Right, so go ahead and look in the link description for the questions to try on these that relate to these examples in the book.